In this video, we are looking at aggregation in Java. Now, before we start with aggregation, let's review some general information about our classes in Java. We said we generally have two members in our classes. The first member are fields, which we use to store data. So any field that we use to store data, or any variable that we use to store data, that's what we call a field. So for example, if we have a student, one of our fields could be the student name or the student ID, which are usually in a primitive data type. The other type of members we have in our classes are methods, and we use methods to perform operations. For example, to calculate the GPA for that student or to get their name or their ID. Now, our fields do not have to be primitive data types. We can have a different type of fields, which is an object of another class. If you have one of your fields as an object of another class, in that case, you have an aggregation relationship between these two classes. So when you have an object of another class in your class, in that case, you have an aggregation relationship between these two classes. So generally, to know that you have an aggregation relationship, you will have a has-a relationship between these objects. So if you look at this example, we have a course class. This is our class course. And we have, these are our fields. We have the course name, which is a string, the instructor, which is an object of the class instructor, and the textbook, which is an object of the class textbook. So the course class has an instructor, and the course class has a textbook. And that's what we call an aggregation relationship. You will see in the UML diagram, the class that contains objects of another class, you have this diamond shape, which indicates that you have an aggregation relationship between these classes. So the course class has an instructor, it has an object of another class, and it also has another object of the class textbook. So it has a textbook. So we have an aggregation relationship between the course and the instructor, and we have an aggregation relationship between the course and the textbook. So let's look at an example here in Eclipse. I'm going to create a new class in this package, and let's say that we have an employee. So I'm going to create a class called employee, which I will be storing information about my employees in there. Let's say we want to store the ID of that employee, and remember, instance variables have to be private, so private integer ID. And then I want to store also their name, so private string, and I'm storing their name. Now for each one of them, I will create a getter and a setter, so public integer get ID, and that will be my getter for the ID, and we are returning this .id. Same thing for the name, so I will create a getter for the name, public string get name, and that will return this .name. I can also create a setter for each one of these objects or these variables. So public void, and we are setting the ID, so set ID, and we'll be taking that ID as a parameter for that method. And we are setting this .id equal to the ID that we pass for that method. Same thing for the name, public void set name, and we are taking the name as a parameter, so string name, and we are setting this .name to be equal to the name that we passed as a parameter. Let's also create a constructor here. So the constructor will have the same name as the class, so public employee. And this is my default constructor that does not take any parameters, and let's leave it actually empty for here. And let's create another constructor that takes both these variables, so public employee, and it will take an integer that represents the ID and a string that represents the name. We'll set these values, so this .id equals ID, and then this .name equals the name that we pass when we created that project. Now, so far, nothing new. We are just creating the ID and the string. Now, the string is considered a class. So in a way, we are also having an aggregation relationship here. So the name is an object of the string class. So the employee class has a string. So we have has a relationship in here. But let's make another class. Let's say that we want to store the address of that employee. And instead of storing the address as multiple values, so instead of storing the address as the city, the street number, the zip code, and the state, let's say that we want to create a class to hold the address. So my class address will hold all the information about any address that we want. So let's go ahead and create that address class. So I'm going to create a new class, and I'm going to call it address. So in this address class, I'm going to create some instance variables. So private, let's call it number. This is the number of the street, so integer number. And then let's put the street name, so private string street. And then let's actually just leave it with the zip code also. So private zip, which is an integer. So I'll leave it at 3 instance variables in here: the street number, the street name, and the zip code. I will not store the city or the state for now. And I'm going to create a getter and a setter for each one of them. Now, a fast way to do or to create getters and setters, I can go to the source menu in here, and I can generate getters and setters. I will select all my variables, and when I click on generate, that will generate the getter and setter for each one of these instance variables. So you'll see that I have the getter for the number, get number. I have the setter for the number, so set number. It's taking the number and it's setting the instance variable number to that value. Same thing for the street, and same thing for the zip code. And let's actually also create a constructor. So public address. Let's create the default constructor, and then let's create another constructor that takes the values that we have, the instance variables. Now, the reason I'm creating the default constructor is if you create any constructor in your class, Java will stop providing you with the default constructor. So if you created any constructor in your class, you will have to also provide the default constructor. Otherwise, Java will not be providing that. So integer number, comma, string, street, and comma, integer zip. And we'll set these values. So this dot number equals number, and this dot street equals street, and then this dot zip equals zip. So now I have another class called address, and I'm storing the address details in this class. Now, we said that each employee will have an address. So I can create one of my fields to be an object of the class address. So one of my instance variables in here, I can have it as the address. So it's an object of the class address, and we can call it address. So now we have an aggregation relationship. We have an object of the class address inside our employee class. So we have a has a relationship, so the employee has an address. So we have a has a relationship, and that's my aggregation relationship. Now, since I added a new instance variable in here, I will need to create also a getter and a setter for that variable. So I'm going to create a getter for the address, so public. And since it's returning an object of the class address, my return type will be an address. And we'll call it get address. So this will return the address, the instance variable address. So return this dot address. I can also create a setter for that. So public void, and I'm going to call it set address. Now this method will be taking a parameter which is an object of the class address. So my data type here is address, and let's call it also address. So what am I going to do? I'm going to set the instance variable address to be equal to the address that we passed in here. I will also need to change the constructor here if I want to create an object with the address at the same time. So in here, I'm going to create the constructor to take the ID, which is an integer, the name, which is a string, and the address, which is an object of the class address. Inside my constructor, I will set that address, or the instance variable address, to be equal to the address that we passed in this constructor. Now let's go to our main method in the main class, and let's actually create some employees. So let's have or add some employees to our company. So to add an employee or to create an employee, I will need to use one of the constructors. Either the default constructor, which basically takes nothing, and it will set the default values, which will make my address equal to null, which is not what I want in this case. Or that other constructor, which needs to take an ID of the employee that you are creating, their name and their address. Notice the address will have to be an object. So if we wanted to create an employee, so employee, this is my data type, and let's call it emp1, so employee1, and I'm gonna create or use the employee constructor. So I'm using the new keyword to create a new object, and then I'm using the constructor. Now the constructor will take an ID, which is an integer, 1, and we are passing the name, let's say Sam, and then we need to pass an address. However, my address has to be an object. So to be able to do that, I will need to create an address object here. So I'm gonna create an address object, so address, let's call it address1, and that will be equal to a new address. I'm gonna use the constructor that takes the values, so the number followed by the street name and followed by the zip code. So let's say number 111, street name, first street, and then the zip code, let's put it as 5555. So I created an address. This address is address1, and this address actually is street number 111. The street name is first street, and then the zip code is 55555. Now in my employee, I can pass that address as a parameter in this constructor. So address1, and then we will not have that error. So to be able to use this or to add an address in here, I first needed to create the address object, and then I will pass my address object in the employee because we are expected to pass an address object in my employee constructor. So to be able to create a new employee, I first needed to create an object of the address because the employee has an address inside it. So if we did the opposite, if we started by creating the employee first, we will not be able to use that constructor because it's expecting an address object. So we first created the address object, and then we passed that address object as a parameter in our constructor. Now that I have my employee, I can get all the information about my employee1. So if I wanted to print out the name of that employee, I can go system.out.println, and we can print the name of that employee. To print the name of the employee, I can use the object name, which is emp1.getName, and that will return the name of that employee. So if we go and run this program, it will print Sam, which is the name of that employee. I can also get their ID, so get ID, that will print the ID of that employee, and in this case we'll be printing the number 1. Now for the address itself, if we do get address, it will go and try to get the toString method, which we did not implement in here yet. So since we did not implement the toString method, if we try to get address, so .getAddress, it will go and execute the default toString method that will basically print the object location, which is a hexadecimal address with the package name. So the package name com.chokri.address, and then this is the hexadecimal address. Now if I wanted to get the city specific value in the address, I can get the address, so this will return an address object, and then I can go inside the address and get the street, for example. So what I'm doing here, I'm chaining my calls. So I'm getting the address, and this will return an address object, and then I'm getting the street from that address object. So if we run this, now we will get the street that employee 1 lives in. So employee 1 get address will return an address object, and then from that address object I can get the street of that employee. Now if we had a toString method in here in our address, so let's actually go ahead and do that toString method. So public string toString, and let's override it to return the details of the address. So this dot number, and then we'll concatenate it with the street. So this dot street, and then we'll concatenate it with the zip code. This dot zip. Now if we go and execute the command in here, the print line, to print the object, basically we are calling the get address, we are getting the address and we are printing it. So we are going to the toString method in the address, and that will print the address like we have it in this format. If you want to print a specific detail about the address, for example the zip code, we can go to the address object, so get zip, and that will return back the zip code, and that's what will be printed, which is 55555. Now again, to be able to access the address, I will need to go to the employee, get the address of that employee, and then I can use the methods available in that address. Now what we are doing here in the employee class with assigning the address is not considered a good practice. The reason is we are not copying the contents of the address object that we pass, we are just copying the pointer. So we have two pointers pointing to the same location in the memory. So what I mean here, if I went and changed the address ADR1 and I set the value for the zip to another value, for example 4444, that will also affect my employee. So if we want to get the address for that employee, the zip code for the employee, it's now 4444, which is not implementing the encapsulation. We said if we wanted to change anything in the employee, we need to access it using the getters and the setters inside that employee. So if we wanted to change anything in the address of employee 1, we want to go to the address in employee 1, and then we will change the zip code. So in here, anyone who has access to the address 1 object was able to change the address of employee 1, which is not an encapsulation, or it's not implementing the encapsulation concept. So what we are going to do, instead of pointing to the same object with two pointers, I am going to copy this address into a new object. So the address that we get here, we will copy the values and paste them or place them in this instance variable object. So to do that, I'm just gonna create a new address. So my address, my instance variable address, will be a new address, and we will use the constructor which is taking the number, the street, and the zip. We will take these values from the object that we pass in here. So my new address, the address that we have here, the street number will be the address that we passed in here, dot get number. So we'll get the number from here and we'll put it as a number for this new address. Same thing with the street name, so address dot get street, and same thing with the zip code, so address dot get zip. So in this case, I'm not copying the pointer, I'm copying the values in that address and placing them in the instance variable address in this employee. So if we go now and run our program again, you will see that when we changed the value in the address 1 after we created the employee, it did not affect our employee. Our employee still has the original zip code and we did not change it. If you wanted to change the address or the zip code for employee 1, we can go to employee 1 dot get address, and then we can set that the zip code for that employee. So get address and then dot set zip code, and we can change it to the value that we want. So the only way to change the address of an employee, we will have to be through that employee object. We cannot change it using the original address object, which everyone has access to in here, we will have to go through the employee and change the address through that employee. Same thing with the set address method here, the setter. Instead of making the this.address equal to address, I'll be doing the same operation, which is copying the contents of the address that we passed and placing them in this instance variable. We should also do the same thing for our getter. So instead of returning the actual pointer to that address that we have, we will be returning a copy of that address. So to return a copy, we'll return a new address. And then this new address will contain a copy of the contents of the instance variable address. To get the instance variable address, this dot address, and then we want to get the number. This is the first value in our constructor. This dot address, and then dot get street, and then this dot address dot get zip. So we are creating a new object. This object has the same contents of the instance variable address, but in this case we are not returning a pointer to this address, so they will not have access directly to that address anymore. They will just have access to a copy of that content that we have in that address.